Cool. Hmm. So, um, where should we start? Yeah, so if you saw my post on the forums, um, the structure of that is basically the same as what I implemented, with some minor changes, because once you get into the weeds of things, stuff changes. So at the top level, we have an application that runs to a supervisor that starts to gen servers, one for the object side and one for the event side. So in total, there are 6 amnesia tables that are being used here. I was thinking about what the best way to structure the storage here. I spent a lot of time comparing the different ways that amnesia and prologue index information, and this was the way that I decided on setting it up. So there is a table for events, which is made up of a key, which is composite of transactions, and the event number. So we'll see that in a second. And then there's a meta, which is just used to store information about what the current system time is. On the object side, there are 4 different tables. So there is a class table, which determines there is an object, what is the class of this object. So for example, in events, it's an ordered set. In the case of these tables, these are old bags, because of the reason that you might want multiple per key. And we'll probably have to implement some kind of primitive ordering here, as an attribute, in order to get this to be reliable upon backtracking. Second table is super, so what is the super class of this class or object? And then there's slots, which is just a different form of key value. It's just so that you can have key value storage for objects. But we don't really use that much in these examples. Oh, there's actually 7 tables. I forgot that there's method and no apply as well. Method simply says there is a method name that I'm calling for this object that refers to this object ID. So it's just another way of relating objects to each other. And then there's OApply, which is it's very similar to how Prolog does its storage for predicates. And that, well, for one, it's being indexed on the specific ID of the method. But it's simply that there is a head and a body, and you can use this to execute information. So this stuff sets it all up. And then there's some helpers give me stuff like what are the events that have been put into the table. So we can look at, for example, let's do some bootstrapping, and we can show some examples of what the events look like and whatnot. So let's bootstrap, and then look at all the events since the beginning of time. And you can see they're all bundled up in the same transaction, because this was all part of the bootstrap was all part of a top level AL query, so it all goes in the same transaction. Yeah, so you have obviously some stuff for events where you can write events to the store, which updates the system time, and they go into you provide transactions since you would want to bundle these per query. For objects, what else do we have that we can show? Let's give an example of just scanning a class. Let's pull up the examples. Let's look at the bootstrap process. Yeah, so for example, here we have 3 classes in the bootstrap. We have that there is a class, that there is an object class. There is an object initialized object with class behavior because it's a method, and there's a object lookup for the class behavior because that's also a method. We can do that for other things as well. For example, we've got some supers. So the super class is an object. For example, I don't know why that's not showing the method, but it's not that important. Bootstrap methods, bootstrapped. Oh, is that only the only bootstrap method? That's weird. Not sure, but it should be fine. Bootstrap fine. I don't know why this is. Oh, because I'm only taking one. Yeah, this is the example. We'll get more into the structure of the methods. We're going through the actual kernel. So the next thing to show is that we have a bunch of different symbolic utilities. So this just works like the sort of Norvig style matching. I wanted to just integrate amnesia patterns directly in the way that I was hoping that I could just directly use amnesia patterns in the same way that we use symbols, but that didn't work out. So I had this small little layer to transform these vars into amnesia patterns. So let's have a look at this. I'll show you what I mean. Pattern. Yeah, so you can see if we have this pattern here, it needs to be converted into something so that we can do var-based amnesia scans. That's important for what we need to do, as you'll see. And then we have other stuff, just do unification. And so if you unify a couple things together, what you'll get is a forest of bindings. What do I mean by that? Let's have a look. Let's unify these two together. You've got an example where you're unifying self, name, and then you don't care about this binding with this list here. It doesn't look too well with the formatting there, but you'll get the idea. Name is bound to Alice, and then self is bound to itself, so it doesn't get bound. We can have another example here. We have so how does the unification work in this case? Well, X is bound to X here, so nothing happens. 3 is bound to X here. Concrete bindings get precedence over var bindings, or rather, it depends on what the current status of things is. And then Y will be bound to X. X is not being bound to Y here because X already has a binding that's more concrete than the var. So in this way, there should be some tree to follow for every binding so that eventually it ends up as something concrete. And then there's just other things like variable freshening, substitution, classical stuff like that. Are there any questions before I move on to how this actually fits into the whole system?
Yeah, can you, it seems like you've implemented a few different things. It sounds like you've bootstrapped an object system through amnesia tables based on your
Yeah,
description. Is that correct?
that's right.
Um, and yeah, you just implemented Norwegian matching, which is, I guess, just the algorithm out of what the the AI paper, the AI book.
Yeah, it's just prologue unification.
Yeah,
Yeah.
it makes sense. Uh, no, I'd be interested in seeing how this comes together because, I don't know if every class gets its own table or what, because it just kind of looks like you made some
Um,
bootstrap tables.
no, yeah. So it's not that every class gets its own table. It's that uh, every class relation gets put. Every information about class relation gets put into the table, which is indexed by the object that is goes first to the relation. So if object has a class, then it will be indexed by object. But these all go in the same table right now.
I see. So when you're showing off the table earlier, it's all the same, I guess, event source table. Because I think one thing you didn't mention is that all this is event sourced. Uh,
Yeah,
okay. One last question. I noticed that all your tables have events 0, comma 22. What is the 0? Is this uncommitted?
yeah. So this is no, this is transaction number. So 0 here is the transaction because this is the 0th
Oh,
transaction. You'll
I
see it
see.
when we
So you have
because
22
these are all part
transactions.
of the same. These are all part of the same transaction because they all come from the same eval statement here.
Oh, I see. Okay, that makes sense then.
Yeah. So we can get onto the actual execution if there are no more questions. I think I heard something. Did anyone send a message or something? I don't think so. It doesn't matter. So let's get into the execution, and we'll start looking through some of the bootstrap events. So we have on the right 2 different data structures that we're using as we go through this, continuations and choice points. For now, you can just think of this as like it's carrying program data, but I'll explain a bit more of this as we go through. So there is also like a top level program where it's got active choice point stack, which is just a stack of these different choice points, and then the transaction ID that is occurring for this evaluation statement. Some help here, you don't need to worry about that yet. And then we have like a top level entry point eval. So why don't we look at a first event in the bootstrap to understand what is actually happening here. So there is an evaluated statement in our bootstrap that was went into this. Why was this event created? Well, it was created by this statement that was evaluated set class to class to class. Where can we find that set class? So set class is very simple. Actually, it's just setting. It's just setting the pattern that you give this object as the class. So you'll often see in interpretation in the functions that are being interpreted, at the first line is usually some kind of like substitution into the patterns from the bindings at the active choice point. So for example, you saw like, we have a bunch of unification going on. So there's a bunch of symbols being related to other symbols. So I should be able to say something like, do we have a nice example here? Get class example. Yeah, we have this get class command, right? This is probably the first one that's best to go with actually. So you can see a bunch of choice points get added like as a result of this. But essentially what this is doing is evaluating like with this pattern. So what will happen first is it will see if in the environment these symbols have been set before, and if so, it will like substitute them in so that they have more concrete bindings. Otherwise, it will simply evaluate them as like arbitrary symbols, which is what's happening here. And therefore it's able to, well, the first result is this, it finds whatever it finds first in the table. What getClass is actually doing here is it's scanning the table. So let's look. Yeah, substitutes in the object pattern and class pattern from the bindings. And then if there is like a map in the object pattern, then there's a special case because it's not like it's not a reference to something in the table. But what I'm saying is, don't worry about this part yet. What we care about is the fact that this is going to scan the object table using like the pattern that was given. So the scan class, what it's going to do is it's going to take patterns that you've provided, and it's going to turn it into a valid amnesia query, preserving information about which parts are variables, so that you can either perform like a vague scan of like find this var to this thing, and return multiple different values, or just like do a more concrete query. And then it will take all of that, it will scan everything, and if it doesn't find any values, it will backtrack. We'll talk about what backtracking does in a moment, but if it does, it will simply load all of the choices that it found for the bindings into the choice point stack and then run with the current active choice point. So with that, we should talk about maybe how backtracking works, which is just a case of pop something from the choice point stack, and then rerun the program with that choice point. So for example, you can see all of these different answers for our query get class A, B were loaded into the choice point stack, but we return what we currently have is the first value. So if I were to do something like ale.backtrack, does it continue? Let's continue. I think I have a top level for this, right? Continue. No, it's special. I need to code this with to get this one out of the way. Yeah, and you can see now it's returning a different value to from before because it's just popping the next one off the choice point stack and continuing execution. What does it mean to continue execution? How does execution finish? Well, this continue is called at the end of interp here, I believe. Nope, this just says AL, but it's going to reduce through, right? Yeah, it's going to continue through them. And then what does continue do? It checks if the goal pointer is greater than the number of goals. So you'll see as the program executes, it's got a list of goals that are to be executed. If the goal pointer gets higher than the number of goals, then it will just finish. It will just say all the goals executed correctly. This is the maximum amount of information about the program that we can get. We're finished. Otherwise, it will like try to take something from the goal stack and then execute that command.
Do you mind if I ask a dumb question?
Yeah, go for it.
Where am I seeing the values? I see your choice point, but where am I seeing the value it spits out? You said I could see a different
bindings,
value.
The bindings.
Okay, bindings. What did it pop up before? It looks like, okay, B is behavior, A is an
So here we've got, yeah, so I'll just slow down for a second and show this. So we perform the statement, get class A, B. So this should return like everything that's in the class table, right?
Yes.
And we agree on that.
Yeah, I agree.
Which it does. It returns everything. So the first, it will just return us the first one, basically, which is A is lookup, B is behavior.
I see, and I can see a bunch of them here, like behavior and allocate class here. So you do this all up front. So it looks like it's kind of a weird choice point because it looks like you eagerly filled out every single alternative. I would expect it to like just remember, okay, we're at this point, and to maybe fill in values if it's disregarded. But it looks like you just eagerly grab all of them.
Yeah, I mean that's an optimization, right? Like it doesn't matter whether you do it eagerly or lazily.
Yeah. It's just because I know in Prolog sometimes if you try to grab everything, it's incredibly slow. Whereas if okay, cool. I just wasn't sure because I wasn't sure what I was looking at exactly, but that makes sense now.
Yeah, you're right. This would definitely be better as like some kind of engine. I agree. That's a good point that I hadn't thought of. Thanks very much. Where were we? Yeah. So obviously, if it finds nothing like in a table for whatever you're querying, then we'll return bindings nil, and then the program will fail. And if it backtracks until there's no blind choice points, the program as a whole fails. What should we look at next? Let's look at application. So a lot of these sets work the same. They're not that interesting. Where's the first one that we can find that's interesting? There's the apply, which is like, this is just the method. This is the head of the method. So we'll take an example of this in a second, and then there's some body that's being added. So this is like an AL subprogram. We'll get to this in a moment, though. Is there anything more in terms of like that I really need to show? The gets are obviously self-explanatory if you know what get class does. Same for get apply. Yeah, no, we should just go straight to exec. So let's take an example of exec. Exec and send. Yeah, let's try this one. So what this statement does is like executes a known method with a head. So usually in an object system, what you would do is you would send to an object and it would look it up through an inheritance chain. What you're allowed to do within the system is you are allowed to simply invoke a method passing in arguments like a function or like a predicate. So what this will allow you to do is simply say, give me the meta class for initialize class. And what this meta class method actually does is if you look in, we could probably just do this from the yeah, no, I don't really feel like doing that. We can look in the application. It's probably the safest way to do it.
Do you mind if I
Let's
ask
look at
you a
meta
question?
class. Yeah, go for it.
Like I know one thing that we did with our object vlisp code is that we integrated the object system into Prolog itself, so the terms look like just normal Prolog terms being called. Right. That was one of the things. Is that possible? I guess this is a thing for later. You're just showing the construction, but I'm guessing you could do the same with integrating this into Elixir, right? Like I assume that you can do function calls. What? You do a function call, make it look like a function call for the functions, right? Like you could do like al.meta class, and it would just do that. I think you can do similar kind of bootstrapping.
Yeah, you definitely could. Like you could just do some macros for sure, and these would end up as the data that goes into the email statement for sure. You could totally do that.
Yeah, cool. I was just curious because I just see like
I know it's ugly.
Yeah, cool.
So yeah, so we have a meta class method which takes self, class, and meta, and it will say, give me the class of self and bind it to class. And then it will say, give me the class of class and bind that to meta. And so these should be filled out with the object, its class, and its meta class. So yeah, when we get to the execute meta class method, you can see that what comes out of this in the first place is a bunch of weird bindings. Why do these look weird? We'll talk about how execs work now. But you can see that like the top level class value was bound to class C485, which was bound to behavior. And then meta class was bound to meta C485, which was bound to class. So behavior is the class and the meta class is class, which is what you'd expect. And then we have like a couple weird markings in the choice point stack, which we'll get to. So let's go to exec. As usual, we have a method ID and we have some bindings that go into the head of that method. These get substituted with their values from the current bindings of the active choice point. And then we run a scan on the OApply. So we scan the OApply for just the head and the body of the method ID. If we find it, then we are using something called a freshener. The point of a freshener is so that it's essentially like doing Jensen like in a macro. Like you want your macros to be hygienic, so you need to freshen some symbols. That's all we're doing here. Because whenever we have like whenever I'm like defining these methods, right? Like I'm defining them in terms of like symbols that occur within like the predicate or like within the method. So these all need to be freshened up basically so that there's no clashing with the current bindings. And this is how the WAM does it actually. I know it looks a bit odd, but this is like how the WAM actually does the thing. It doesn't like have like separate scopes for where execution occurs. I believe that's mainly like an efficiency thing, so that you can like do undos faster. But yeah, well, freshen the head and the body, so I could even show like like an example of freshening here. Yeah, you can see like self got freshened for self 7963, and that's, yeah, it got provided with some freshener. This should probably be deterministic, because if you run it again, obviously the freshener will change. It's not something we necessarily want, so probably there's a better way to perform this. But it's not just like a thing. So
Don't you just need a deterministic seed and some like seeded chain for that or something?
Yeah, but you're right. It should be easy. I just didn't think of it, but it should definitely be deterministic. And so it will unify the bound head and the method ID pattern with the ID that it found and the head of the method that was found, in order to instantiate these freshened variables with whatever is we're supplying in the arguments. And then it continues running the sub goals. And then it pushes something called continuation to the start, which is just, there is some information about what we were running beforehand, before we entered the sub goal. And when you're done with the program, you need to pop this continuation and keep running from there. So if we have a look at continue here, you can see that if there are no more goals to run, it will see if there's a continuation, and it will simply take the continuation's goal pointer, it'll take the scope pointer and the goals, and then keep running those goals. So this is how you get in and out of calls. And it will also, of course, take the bindings that were found from the subgoals and like keep going with them. So bindings are like monotonic in this regard, virtuous point. So unless you start backtracking, you don't really ever decrease the number of bindings that exist. You can probably do some cleanup here and there if you like. There's probably opportunities to do things like garbage collection, but I haven't thought too deeply about this. There's probably all kinds of optimizations, but for now there's no such thing. So this could just like build up garbage from calls forever. What's next? Yeah, so that was metaclass. That was execution. Let's look at another example. So we've done exec, we've done get class. Cut. Yeah, there's a bunch of like different helpers that you need to have. So there's not just exec, and there's not just you also need some control flow. So for example, there's cut. So you know how before we had like a bunch of different choice points that were coming out of like coming out of our query, and we're also setting a marker. What cut does is it simply prunes all of the choice points from the point at which like a top level goal was entered. So each mark marks the freshener so that it can like prune all of the choice points that are associated with past the marker. Since cut is like a continuation level prune operation, so we can take a look at how exactly this works. Examples.al.cut. Oops. And you can see now we only have the first results that we were given. You might want this for obvious reasons. You don't want to always search everything. It can lead to various problems. We also have implies then. So this is a similar kind of thing in that it's pruning choice points, but it's only pruning choice points under certain situations. So what does this say? This says, how to read this. This says, run this. If it succeeds in that like there are some bindings returned, then run this. If it doesn't succeed, then run this, which is nothing in this case. But it doesn't just mean like, then run this, because that's just prologue, or right. What it actually is run this and commit the results. Like, don't rerun this, like don't subject this to backtracking. And so you see, you've got like a get class, object class, then run class meta class. So object will have like a binding, class will have a binding. So there is it will only look up the specific meta class behavior. And so it only returns one result. So this is obviously useful for cases where you only really care about the first results. It just offers some more fine-grained control over your program. We use this within the Bootstrap. Where do we use this? We use this for implies. Yeah, we use implies for doing message sends. I think lookup uses or, and then send uses implies at some point. So let's look a bit more in depth at the execution of implies. Yeah, so this just places some information into the goals, some condition, and then sets a marker. It sets like specifically it sets an implies marker, which means that when it succeeds, it gets print back to the implies marker, and everything goes on pub. Or is kind of the same in that like, or is a little bit simpler actually, in that like it's like implies, but it doesn't do the cut. Anything else? Just go over more of the. Yeah, we can go over some of the more specifics. So send is the like, normal object level message send, and that like it follows the object-oriented way of executing sends. So it takes an object, it takes the name of a method, and it takes some bindings that you're going to provide as arguments to the method. So let's say we wanted to make a new object. We could use this method that has been assigned to class. So you can call new on class, and it will return, and it will send our information to this method here. So since the class of class is class, that means that when you look it up when you look up the method on the class, it will find it on itself. So how does send actually work? Send takes the object that has been provided. It takes a method name, so new. So we have class as the object, new as the method name, and then we have a bunch of different arguments. Let's find out here. Yes, this is some information about an object that we want to create. So the name of our object is point. It's superclass as object, and it has no slots. And then it will return this variable that gets bound to the ID of the object that we're creating, which should be point. So in fact, we should be able to just do especially. There's no reason to not do this. So what exactly is the execution? Well, first it looks up the class on the object. Assuming this works, then it will continue execution, and then it runs this imply statement. So what it will try to do is exec a lookup on the class to see if it can find a method ID with the name that's matched to the name on the class. So the class of class is class. So this says lookup new on class and give me the method ID that it's related to, which should be, in our case, a new object. If that succeeds, it'll say calling the method ID from class with the args. Actually show what this can do. Oh, I accidentally put a How did I even press that? I shouldn't even be able to do these backslashes on. Okay. Okay. Whatever. We don't need to reboot strat since this is all like part of disk. Yeah, and you can see there's like a huge execution here. That's okay. You don't need to worry too much about this. Actually, is this doing it multiple times? That's weird. Huh. No, like copy. Why is it doing that? Pulling new object, pulling allocate, pulling initial animation, pulling new object. Oh yeah, but this is fine actually. It's doing this is the execution for make point object. So we can go through this a bit more specifically. So it will like get class, it will look it up, so it will find new objects, and then it will call new object from class with the arguments as according to the logic it implies. And this is the arguments that it's providing. It is executing new object with class with this information about the new class, and then the binding that we want to supply because we want it to get something out of it. And so it will execute new objects. New object simply runs allocate. New object sends to the self that was provided, the self being still class. It calls allocate on it, and then returns the allocated variable. What does allocate do? Allocate is allocate class, which doesn't really actually do anything. It just provides a dictionary. Earlier I said that you can do like get class, and like if you do get class on a dictionary, it will actually just return with the information that's in a dictionary, so there's no scan required. And that's useful for temporary objects. But the allocated information, the allocated memory then gets initialized with the arguments returning the actual like class. So initialization works as follows. It works just like Jeremy, you'll know how this works from our prologue work on Object-Lisp. So it just says, well, what's the class on my class? Well, it's class. So we'll set the name, which was the name of the class that we were creating, which is point. We will say that the class of point is class. We will set that. And then we will say the class of point is whatever I put in a super, that's objects, and then the slots are empty. So these two should both succeed. And since it will succeed, it will return whatever was bound to args at new. So args was provided, new is what we're getting out here. So new has to be initialized. It's not actually being initialized, so that's not what rate this should mean. But it doesn't matter because we were calling point directly anyway, since we knew up front. It's not really a big deal. It doesn't actually change like the logic, it changes how we call it. And then we have some behavior. I forgot where we were. My brain. Yeah, we just executed that and it's finished. So we have a new object. Okay. So we should see at the bottom here that we have a new point class. There is a point object, new point class is new 3903. Really what this should be doing is just like returning as like some final return where it just provides the top level bindings, but it's not that hard right now to see what it is. It's a nothing. That's fine. But the actual example is then you send to the new point class the new the thing. You don't care what you're sending in as arguments, and then you should get point objects. So then we call on points, we call class new, we call the method new, a method named new. So what is this going to be? Is this going to be a new object again? Yes, it is. So what this will do is it will look up the class on point, which again is class. We'll call new object with these arguments. So we get back to new objects and we do allocate again, we get a dictionary, and then we send init to that allocated dictionary, which is like a class point or something like that. Yeah, so if I look up what alloc is going to be at some point, there'll be an alloc somewhere. Yeah, you'll see there's self AB4C, and self AB4C should be smart.
Do you mind if I summarize something? At least what I think is going
on?
By the
Oh
looks.
yeah, here we go.
Okay.
Sorry, go ahead.
Yeah, so it looks like what you've done is one, implement some kind of prolog engine, right? That's where all the choice point stuff is. And using this prolog engine, you've effectively implemented the object vlisp, I guess, object model on top of that using OWL. Am I correct?
Well, it's a bit more complex than that, and that like the storage mechanisms are different. So Prolog just stores a bunch of like big bits, whereas this is storing this has more refined storage and scanning, and that it's like doing it for like the object level. But more or less, it's the execution is identical to the one, yeah.
Oh, sure. I understand you've had to basically implement this with like gen servers and amnesia tables. But
well, it's more that there are like optimizations that we can make to like storage and retrieval because of the fact that we're doing this from like an event source position rather than from like just having so like we're not rerunning a program every time that we open it up, and be like the tables work differently. Yeah, the storage and retrieval can be like more efficient as a result of the fact that it's not. That it doesn't have to index on predicate heads, for example. But yes, the execution is identical to the one.
Yeah, but I guess the other part that I'm just noting is that what's neat about this is all this is OWL code. That you basically bootstrap the object system with basic OWL code.
Yeah.
Well, but there's, I mean, just to, you'll have to forgive me, it's like 6 in the morning here, but I wanted to summarize my understanding of the system, and you can tell me kind of what I'm wrong about. That's okay. We have a minute here. Okay,
Yeah,
so my understanding is that we have some, I guess Jeremy puts it, Prolog execution engine, which is basically just, to radically oversimplify, a giant set of bindings with various degrees of resolution and some rules for how we go through that and how we kind of, given, let's say that we have like some information at time t, unification allows us to go through the information we have at time t and figure out what we can derive from it, right? Like, you know, without any new information at that time. And that might be, you know, resolving relations between symbols, right? And that's the prologue that has no necessary object structure, right? But then on top of that, you've bootstrapped an object structure through sort of two parts. Part of that bootstrapping is in AL, and part of it is also in, I guess, like how you do eval, or there seem to be parts of the object structure that aren't just like unification that are implemented in Elixir here, right?
yeah. So everything, the whole object system is bootstrapped through the command log here. So each top level eval statement in AL is a amnesia transaction, which means that it's like an asset transaction over the object system. So the command log is just like some fixed primitives or like how you like operations over objects. Like for example, there's an event set class. There's an event there's like a set list of events, right? Like you can understand, like
Yeah, and some, I
you can
mean,
read the events
presumably,
and then replay it to get to
would
the
it be
state of the
correct
program.
to understand that like the structure of an object system, and so what we're calling an object system here is really a sort of like particular set of patterns of logical derivation, which are
Yeah.
the bootstrapping code of the system.
It is, yes. So whenever you run, it will actually like hydrate all of the events that are in the system that you have committed, to like hydrate your object
Right,
system.
right.
But
Okay.
yes,
So then,
they're just a bunch of relations. Yeah.
yeah, my question or one question is when you talk about something like an object send in the system, what you demonstrated looked to me to be two things happening at once, which seem at least sort of logically independent, but I wanted to check if I understood that correctly. So, one, when I send message to an object, one thing I would understand that to be doing in the system is just like basically adding a fact, like saying that like this message is now sent to this object. Like I'm just adding, an event or a fact, whatever we want to call it. I'm asserting something about the history of the system. And then based on that fact, now it might be possible to derive more things, right?
Exactly.
And it seemed to me that both of those things were happening, like just they happened to be coupled, even if they don't need to be logically. Is that true?
They are coupled, and it's the way I would describe it is you're setting up a channel between like yourself and an object. So like you're sending information, you send information to the object, you receive information back. And they can be, there are ways like you can couple them, but
Well,
they
but they
don't
don't.
necessarily.
I mean, an argument in favor of decoupling them could be that there's some time involved in computing, at least computational time involved in computing derivations. And who knows where the facts, like sending the messages to objects, wherever that happens to be coming from, um, maybe, I guess we have transactionality. So there, if you wanted to input multiple pieces of information at once, there's already a way for you to do that. But yeah, that seems to be that's like a system design choice, right? It could be.
Yeah, you could do it either way, because like if you wanted to do it that way, you would just make two separate calls in the same way, and you would just simply not return any specific new information.
Yeah,
It would
I
simply
mean, I
say
do.
the call works.
Right. I can see that there's a natural reason why you would want to, let's say, derive enough that you could determine what the response to the message is, right? Because this then allows the
Yeah.
caller to do other things. Do you derive just that much, or do you also derive more? Like you could potentially derive more from this fact, I would imagine.
I mean, it depends on the program that you're writing, I think, as to how much like you want to derive. If you could send a message that is just give me some information, you could send information that's complete right, and you can do something that's like a mix of both. But the important thing here is that this is all happening within like a transaction over the system, and importantly, there's two like different levels of commit here. Right? There's like commit to there's like an AL level commit where you've evaluated, you found some bindings, and then you sent all the information through to the event log and object system to be propagated. And there's also the level of committing to a choice point on a link, which can be rollback. There's also things like cuts and whatnot. So so it depends on like what level you're trying to write the application.
Well,
But yeah,
that's helpful.
so you can see that as a result of all this, like there was a transaction generated that added a bunch of different events that just like created this point class, and then at the end of everything, but we ended up getting this we ended up getting this point object out, this temporary point object that we can use for other things.
I have a minor question. So a lot of these
Yeah.
trace points are fairly ephemeral. Would you agree? And that after we cut away, it can be done away with, right?
Sometimes.
So can we like? Is this all added to the event log, or how does that work? I'm just curious.
Everything. Things that go into the event log are stuff that has been like called during the Amnesia transaction. So there's no like special transaction overlay, but there is like if you do some backtracking over after doing like a mutation, it won't automatically undo.
Yeah.
Which is why like if you do a mutation on the event log, you should do a cut of some kind. You should like do some kind of commit so that you like, accidentally do like a backtrack. Unless that's something they want to do for whatever reason, your application is doing something weird.
But what all I just mean is that like the intermediary choice stuff, we can, I guess, squash away in the history, so it's not just like ever growing, right? Because it's not really essential information, unless it's wrong.
Yeah, of course. Yeah, you can squash this stuff, and you can do like snapshots of the, because this works as like a command log, so you can apply the like body command log theory to like having snapshots of the object system and reducing the amount of history and stuff like that. It should be fine. Something like XDDB does as well, but they don't use like objects; they just use command logs.
That's cool.
Yeah, it's the done thing in these kinds of systems. But yeah, that's the current state of AL. So I'm trying to. There's obviously like a lot of different directions in which like this whole thing can go, and it would just be good to like have an idea of, have some discussions on where we want to go with this next step. Obviously, like I have a ton of different things like that I've thought of, and I've got like a bunch of like documentation in the works. Like I'm expecting to use the prototype repo as like the for now it should be like the centralized hub information about like what AL is, I think. Since it's the most like concrete like, idea of what AL is right now.
That makes sense. By the way, as a side note, I've cut a release for X example, so you won't get the annoying cache miss and cache hit messages anymore.
I don't want that.
Yeah,
I was gonna look into that.
Yeah, it's fixed in the newest release. I cut a release, and it's on hex. It's on hex docs now, so you can update to use hex instead of the git.
That's great. Thanks so much.
Yeah, no problem.
But yeah, I assume if there's no questions, then we can just let it sit for a while. But it would be good to like have some thoughts about where we should.
Thanks for the presentation. This is helpful. I think it would be good to have a discussion or at some point about next steps. I will need to think about at least what my position is on that. One thing that would be helpful to me, and maybe this is just like my brain reading the stuff, but we're clearly making some sort of, let's call them essential structural commitments or essential structural design decisions here. And I have a rough understanding of what they are, but I don't have an exact understanding of what they are because it's like mixed with like basically a bunch of implementation details. And if we could extract those into some minimal document, it doesn't necessarily, I'm not asking for like specific mathematical formalism, but if we could just get a minimal, like what are the design decisions in AL right now that we can interrogate and build on, I think that might be helpful. At least it would be for me.
Yeah, the docs do have like some stuff on like some of the specifics about indexing and but yeah, usually some of the more like fundamental design decisions here should and like what the design decisions are. Like I will try and write something up on that so that we can
It would be
You have
helpful. Also, it would be
less
cool.
money to-
Presumably, some of the design decisions kind of imply other ones, like there's some
Yeah.
hierarchy of design decision making choice points there. Would be cool to see that. I gotta run. Thank you very much.
All right. Thank you very much. Does anyone else have any questions? Oh, I think Artem
Here he left.
appeared.
Yeah, he said he was
Yeah.
busy. I'm going to cut the video here. Thank you everyone for watching this wonderful video of learning more about AL. See you all next video. Hopefully it'll be sooner than a year from now.